Let's talk a little about review trig solving trig functions. Some of us are still really struggling with this, and so I'm going to remind you on the onset that this is just about solving for x. Like, yeah, we're solving for a sine of x, but that's because it's a composite function. We got to treat sine of x by itself like a variable and solve around it, and then ask ourselves at the end if we can use what we know about sine to come up with actual values just for the x. Let me demonstrate what I mean. So if we treat sine of x just like a variable, I need to get it by itself. So the first thing I'm probably going to do is divide by 4. I'll do this because I want to deal with the square root separately, and I know I can get that equal to 1 right away. And so now, if I'm still trying to get sine x by itself, now is the time to divide by square root of 2, thus leaving sine of x all by its lonesome. So let's go ahead and write that here. Okay, so we have sine of x is equal to 1 over square root of 2. Now we know that that's not an acceptable way to leave it. We need to go ahead and rationalize that denominator. And so let's take that as square root of 2 over square root of 2. Okay. If we do that, we'll end up with square root of 2 on top, square root of 2 squared on bottom, which is just square root of 2. And on the left-hand side, I'll end up with just sine of x. Now here's the part where we have to depart from like normal algebra solving pathways. We're looking at for sine of x to be square root of 2 over 2. This is an exact value, so we can actually go to our unit circle and ask ourselves this question: when is sine of x equal to square root of 2 over 2? Well, remember, sine of x is a y value, so it's the second value listed. It looks like we have a couple places. Here's one right here where square root of 2 over 2 is going to be our x value. So that's going to be at 45 degrees or pi over 4. And if we come over here, we also have square root of 2 over 2 being our sine value or y value, and that's going to be 135 degrees or 3 pi over 4. We have the negative versions down here, but we're not interested in the negative version here because we're just looking at the positive square root. And so it looks like our two answers will be 45 and 135, or if we want to write them in radians, pi over 4. Okay, so let's write this down. So x is going to equal to 45 degrees, 135 degrees. Or if we want to express it in radians, because it's unclear which one we should be doing, we're looking at pi over 4 and 3 pi over 4. Okay? And so again, on these type of problems, we're just solving for x. If you keep that in your mind that we're just trying to get sine of x by itself, or whatever the function happens to be, and then evaluate that function individually, might lead us to a little more success. And so again, just treat sine of x like a variable. In fact, one of our tactics early was to replace it with a variable so it was a little bit easier to see. If you don't need to do that anymore, that's totally fine. But in the end, we're just trying to get x by itself. That's what we're trying to do in part B as well. Now this one might demand a little more work up front before we can start solving, because we have more than one function here. But you guys have experience with like identities and how to cancel things out, and so this shouldn't be too tough of a task. So the first thing I'll probably do is distribute through, just because I don't want to be dealing with like parentheses within my function. And so we'll end up with here, let's see, sine squared x minus sine of x times cosecant x. And that's going to equal 0. Now, sine squared of x, that's something I know how to deal with, but sine squared x cosecant x, that's going to be a little bit tougher. But if we look at cosecant x and remind ourselves that we can rewrite this a different way, and so let's see, sine squared x minus sine squared x, or sine x, excuse me. Let's change colors. Cosecant x I can express as 1 over sine of x. Okay, so that's a direct replacement from cosecant of x to 1 over sine of x. Well, if I take sine of x and then I divide by sine of x, that just becomes 1. And so essentially this is sine squared x minus 1 equals 0. Okay. Now from here, it's just a matter of solving. So I have sine squared x minus 1. And so treating this just like a normal variable, let's go ahead and add 1 to both sides. I'll end up with sine squared x equals 1. Now to solve, just treating like a variable, it's a squared value. So let's square root both sides. And so we end up with sine of x equals, of course, plus and minus 1. And so going back to our unit circle, we actually are going to have two different values because we need to know when sine of x equals 1. And we also need to know where sine of x equals negative 1. Now, of course, remembering a sine is going to be our y value. What we're essentially saying is when is a y value going to be plus or minus 1? Well, we're going to have 1 up here, and we're going to have 1 down there. And so our answer sets should be, when it's 1, it's going to be 90 degrees. When it's negative 1, it's going to be 270 degrees. Or if we want to express it in radians, 90 degrees, same thing as pi over 2. 270 degrees, same thing as 3 pi over 4. Okay. So I'm actually going to pause the video here. I'll take care of, I think I want to answer 6 separately because there's a lot more to do, and it's a completely different problem here than problem 5. And so again, the gist of these problems is to treat sine of x or cosine of x. So what do we have? Just like a normal variable, solve around it, get it by itself, and then let your trig take over at that point. Thinking about your unit circle in this particular case, because I actually ask you to limit your answers to unit circle answers. But of course, they end up being really weird. You could use your calculator and the inverse functions to find it. But that's what we have for part 3 here. So we'll jump back to answer number 6 completely separately.